Okay, you can see we've already created our velocity time graph. Let's just talk it through to make sure it makes sense. We've got a car starting at rest, so it has to start at the origin where the velocity is 0. And then over the next 6 seconds, it achieves a final velocity of 20 meters per second. So we simply just connect the dots up to 20 meters per second. Then it remains at this velocity for 4 seconds, so it stays at 20. Then it slams on the brakes and gets back to 0. And that takes 2 seconds, so we're already at 12 seconds here. And then it says it's in reverse, and for the next 8 seconds, it goes in the other direction, so in the negative direction, and achieves a final velocity of 5 meters per second in reverse, so -5. So you can see our final line goes from 0, where he stopped, for the next 8 seconds down to -5. So there's our shape. Let's label the regions so we can keep track. We'll call that region 1, 2, 3, and 4. Now the first part asks about the acceleration. Now you'll remember when you see a VT graph, you have two choices. We can do slope or area. Slope is going to give us information about rise over run. So if you look at the units, the slope is going to tell us about meters per second divided by seconds. Rise is measured in meters per second, that's the y-axis. Run is the x-axis measured in seconds. So that's equivalent to meters per second squared. So slope is what we're going to do to find acceleration. Let's do region 1. Now if I look at region 1, the rise is 20 and the run is 6. So in region 1, my slope is 20 meters per second divided by 6 seconds, which gives me a positive slope because it's going from lower left to upper right of 3.33 meters per second squared. So I'm accelerating at 3.33 meters per second each second. Region 2 is flat, so the steepness of the line is 0. No acceleration. Now remember, acceleration is the rate of change of velocity, and it says it's a constant velocity, so that means you're not accelerating, you're not changing your speed. Region 3. Region 3, we can see we're slowing down, and the slope is negative, so we know the value is going to be negative. Here, the rise is also 20. The run is 2 seconds. So in regions 3, I would say the slope is 20 meters per second, but it's going down, so negative, divided by 2 seconds, which gives me an acceleration of -10 meters per second squared. And then region 4, the last region, the slope is also negative, and it looks like the rise is -5 and the run would be 8 seconds. So -5 meters per second divided by 8 seconds gives us another negative slope of -0.625 meters per second squared. Now, the only thing left is to answer the question on the total displacement. So we've looked at the slope, that gave us acceleration. How do we find displacement? Well, the other option is to do area. Let's just make sure what area gives us. When I do area, it's always going to be some sort of multiplying. So for example, if I did the area of this triangle, it'd be 1/2 base times height, and then I've got a rectangle, length times width. You're multiplying. I'm multiplying y-axis, which is meters per second, times x-axis, which is seconds. And the seconds cancel. So it looks like area is going to give us displacement, so let's go for it. Now any area that's above the x-axis, which in this case is the time axis, is going to be a positive displacement, which makes sense because my velocity is positive. I should be moving away from the origin. And any area below, when my velocity is negative, will give me a negative displacement. I'm coming back towards where I started from. So let's do region 1. Region 1, I've got a triangle, which is 1/2 base times height, which is 1/2 6 seconds times 20 meters per second. So area 1 will be 60 meters. Similarly, for region 2, it's just a rectangle. So I'm going to do length times width. And for this one, length times width will be 4 seconds times 20 meters per second. So it looks like region 2's area is going to be 80 meters. Again, moving on, we'll look at region 3, another little triangle. 1/2 base times height. Here the base is 2 seconds and the height is 20. So region 3, 1/2 base times height will give me 1/2 of 2 seconds times 20 meters per second, which gives me an area of 20 meters. And then region 4, we also have a triangle, but it's below the axis, so it's going to be negative. This one has a base of 8 seconds and a height of 5. And 8 times 5 is 40, but we have to go 1/2 base times height. So it's going to be negative 20 meters. Now if we add up all these areas, and I'll just circle them all. There's area 1, 60, plus 80, now we're at 140, plus 20, we're at 160, minus 20, we are back to a total displacement of positive 140 meters.